A ghost just shouted from orbit. The signal was impossibly loud, startlingly brief, and came from a piece of junk that has been silent for over half a century. A long-dead satellite has just spoken for the first time since the 1960s, and its message is a chilling new mystery for the modern space age. This isn't science fiction, it's a real event that has astronomers buzzing with excitement and a touch of concern. The story of so-called zombie satellites is a strange but surprisingly real chapter in the history of space exploration. These are spacecraft that, after years or even decades of silence, suddenly show signs of life. One of the most famous cases is a satellite known as LES-1. Launched by the United States Air Force in 1965 to test military satellite communication technologies, it was part of the Lincoln Experimental Satellite Program. A wiring error left it stranded in the wrong orbit, and its mission was cut short. The satellite officially went dark in 1967. Then, in 2012, an amateur radio astronomer in England detected a peculiar, repeating signal. After 45 years of silence, LES-1 was transmitting again. Investigations concluded that the satellite's original batteries had likely disintegrated, creating a short circuit that now allows its solar panels to power the transmitter directly whenever they are in sunlight. The satellite's tumble through space causes the signal to fade in and out every 4 seconds, an eerie, ghostly heartbeat from a long-lost machine.
A more recent example occurred in 2018, involving NASA's IMAGE satellite. Launched in the year 2000, IMAGE's mission was to study the Earth's magnetosphere, the invisible magnetic shield that protects our planet. After 5.5 highly successful years, communication was suddenly lost in 2005, likely due to a power system failure. 13 years later, another sharp-eyed amateur astronomer detected a signal from an unknown source and, through careful analysis, identified it as the long-lost IMAGE. NASA scientists were thrilled, confirming the satellite's identity and even attempting to reboot its systems and return it to service. Though they managed to decode some data, the connection proved unstable, and after a few months of flickering hope, IMAGE once again fell silent. But the event that has recently captured the attention of the scientific community is different, and in many ways, far more dramatic. On June 13, 2024, a vast array of radio telescopes in the Australian outback, known as the Australian Square Kilometre Array Pathfinder, or ASCAP, detected this extraordinary radio signal. This wasn't a repeating weak pulse like the one from LS-1. It was a single, incredibly powerful burst of energy that, for a moment, outshone almost everything else in the radio sky. And it was unbelievably short, lasting less than 30 nanoseconds.
When astronomers detect such powerful, fleeting signals, their first thought is usually a cataclysmic event in the distant universe. These are the hallmarks of what are known as fast radio bursts, or FRBs, which are often caused by the collision of ultra-dense objects like neutron stars billions of light-years away. But as the scientists analyzed this new signal, they realized it wasn't coming from deep space. The signal's characteristics didn't match those of a natural cosmic event. They pointed to an artificial source. Through careful calculation, they pinpointed its location to an altitude of about 4,500 kilometers above the Earth. This was a message from our own backyard. The detective work began. Researchers cross-referenced the signal's location and timing with the known trajectories of all objects orbiting Earth. They found only one match, a relic from the dawn of the space age named Relay 2. Launched by NASA in January of 1964, Relay 2 was an early experimental communications satellite. Alongside its predecessor, Relay 1, it helped pioneer transoceanic television broadcasts and even transmitted the results of a U.S. presidential election to Europe. But its operational life was short. Its transponders began to fail, and by June of 1967, the satellite went completely silent. For nearly 60 years, it has been nothing more than another piece of space junk, silently circling the globe on a long elliptical orbit.
So what caused this long-dead satellite to suddenly shout into the void?
Unlike the case of LES-1, this wasn't its electronics spontaneously powering back on. The signal was too short and too powerful for that. Scientists are currently exploring two primary theories. The first, and most likely culprit, is a phenomenon called electrostatic discharge. For decades, as Relay 2 has orbited the Earth, it has been flying through the solar wind, a constant stream of charged particles from the sun. Over time, this can cause a massive amount of static electricity to build up on the satellite's metallic surfaces. After nearly 60 years of accumulation, it's possible this charge finally reached a breaking point and released its energy in a single gigantic spark, like a bolt of lightning on a miniature scale. The second possibility is a high-velocity impact from a micrometeoroid. Space is filled with tiny particles, many no larger than a grain of sand, traveling at incredible speeds of many kilometers per second. An impact from one of these particles, while not enough to destroy the satellite, could have instantly vaporized a tiny piece of its metal structure, creating a small explosive cloud of plasma. This superheated plasma could then have produced the brief, intense radio burst that ACAP detected. This theory is also plausible, as micrometeoroid impacts are a known and constant hazard for all spacecraft.
This single, nanosecond-long burst from a forgotten relic has opened a new window into the space environment around our planet. It's more than just a cosmic curiosity. It has profound implications for our modern, satellite-dependent world. Electrostatic discharges are a known threat to operational spacecraft, responsible for more than half of all anomalies caused by the space environment. These events can disrupt communications, damage sensitive electronics, and in the worst cases, lead to the complete failure of a satellite. Our global positioning systems, financial networks, weather forecasting, and global communications all rely on a fragile web of active satellites. The mysterious signal from Relay 2 is a stark reminder that even the silent, dead objects in orbit can hold surprises. It demonstrates a newly observed hazard, a powerful electrical event that could potentially affect our most critical infrastructure. Studying this phenomenon is no longer just archaeology, it's about protecting our future in space. The ghosts of the space race, it seems, still have important lessons to teach us. They are sending us warnings from their silent orbital graveyard, reminding us that even in the vastness of space, the past is never truly gone.